Hi everybody, hope you're staying healthy at home. First thing we're going to do is start with radicals while we're on this extended learning online plan. This is a table that you might want to clip a picture of, that it would help if you don't know square root or squares, cubes, fourth powers, fifth powers. So let me explain how this table works. Most of you think of radicals probably with a square root like this, but we're also going to get into ones that have a little number here, such as a 3, that would be a cube root. This one would be a fourth root. We could also have fifth roots and so on. So this is going to cover not only square roots that just look like that, but also cube roots, fourth roots, and fifth roots. And I think that's it that I picked for the MathXL. But the way this table works is, let's start with something more interesting than 1. Let's start with 2. So this means the number 2 to the second power is 4, which, remember, 2 to the second power is 2 times 2, and 2 times 2 is 4. So that's where that comes from in the table. 2 to the third power means 2 to the third, which means 2 times 2 times 2, which means 8. And then 2 to the fourth power, so on. 2 to the fourth is 2, 2, 2, 2. And 2 times 2 times 2 times 2 is 16, and so on. So that's what this table represents. Here's 2 to the fifth is 32. The numbers on this table come up quite a bit. That's why this table's handy. So let's just look here. 5 to the third power. 5 is your number, which is like the X in this chart across the top. So if 5 to the third is 125. So that's just handy to know that. It will help you with some of the MathXL questions. All right, so that's how this table reads in a nutshell. What I did is I pulled a few problems from the MathXL that I thought you might want to see done and worked out, and then I think you'll know how to do the MathXL. So if you want to follow along and write these down, you don't necessarily have to print it out, but there is a printout, or you can just write them down as we go. So the first one is right here. This isn't numbered very neatly. So square root of 250. We're going to simplify radicals, and in this case we have a square root. So in order to simplify them, you want to think of the prime numbers that multiply together to make 250. So we are going to make what you might know as a factor tree. So we need numbers that multiply to 250. And if you're stuck on this, it ends in a 0. So it's going to divisible by 10, 5, 2. I'm going to start with 10 because the bigger number you use, the faster you'll get there. So 10 times 25 makes 250. And now I have to keep going with these numbers until they are prime. So what numbers multiply to make 10? 5 and 2. You could have them flip-flopped. That's fine. And these are both prime, so you might want to circle them so you remember. 25, the numbers are 5 and 5. So I have gotten to all prime numbers. That's why I circled them, to know that they're prime. And so what you want to think of is the square root of 250 is the same thing as writing the square root of 2 times 5 times 5 times 5. So this little thing right here is what we call the prime factorization of this number 250. And this is going to help us simplify this square root. All right, so there is no little number out here like I showed you in that other one where we could put numbers out there. So if there's no little number, it's called a root index. It's automatically a 2. And what that 2 means is you need pairs of 2 of a kind. And if you have 2 of a kind, I think of this as like an inside, they're stuck in jail maybe. You need 2 of a kind to get out from under that root. So you could circle, we see 2 5s here. We see more than 2 5s, but we can only take matches of 2. So here's 2 5s. I'm going to circle them and cross them off. And one of the 5s, when you cross out that pair, only one of them gets to go out of the square root. So this 5 is now out of the square root, and then what's left? Well, these two are still left. because they didn't have a pair. And then we just multiply them. What's 2 times 5 makes 10. So our answer to this is 5 square root 10. So the square root of 250 is equal to 5 square root 10. And you might think this is what our yellow calculators at school do for us, but this is the work that the yellow calculator is doing. All right, I have a few more. This will probably be a 10-minute video if you're wondering. There's a few more to do. All right, this time, so number 2 says 4 square root 48. I'm going to write it over here so we can see it. 4 square root 48. So to do this one, I also want to simplify. That means make a factor tree. Think of numbers that multiply to 48. It ends in an 8. So if you don't know that 6 times 8 is, you could divide by 2. Whatever you pick here that multiplies to 48, you'll eventually get down to the same prime numbers. 6 is 3 and 2, 8 is 4 and 2, and 4 is 2 and 2. So pause it if I wrote too fast for you, but I am now down to all the prime numbers of 48. Okay, so now what you want to think of is under the square root. I'm only going to talk about this part right here. Under the square root is, I'm going to group them in order, 2 times 2 times 2 times 2 times 3. And then out in front of it already, I'm just bringing that over. There was a 4 in the original problem. All right, under the square root, we got to find pairs. So here's a pair of 2's, here's a pair of 2's. So from this pair of 2's, I get 1 2 that comes out in front. From this pair of 2's, I get another 2 that comes out in front. And then I already had a 4 out in front from the original question. Remember the 4 was already out there? So I also have a 4 in front. So what's left under the square root? Well, there's only one thing. It's a 3. All right, now what do you do with all the numbers out in front? We multiply them. What's left? So 2 times 2 is 4. 4 times 4 is 16. So it is 16 square root 3 for an answer. So 4 square root 48 is 16 square root 3. All right, now this one is number 3. It's the square root of 25 divided by 49. And these are perfect squares, which means I could look at the body of my table and see 25 under the square one is 5. Square root of 25 is 5. And then 49, the square root is 7. So you're actually going to think of this one as the square root of 25 divided by the square root of 49. And if you don't know those are perfect squares, then you have to make one of these factor trees that we did over here and get down to that answer. But I already know the square root of 25 is 5 and the square root of 49 is 7. And that's where you would read in the body of the table to come up with those numbers. So your answer would just be 5 divided by 7. All right, 2 more. Number 4. We have cube root of 16. Okay, so here's where things is a little different because now it has a number out here. This root index this time is a 3. So I still do the same thing and make a factor tree. And at the end, I'm going to do something a little bit different. So cube root of 16, 4 and a 4 makes 16. A 4 is a 2 and a 2 and a 2 and a 2. All right, so now I have all these prime numbers here at the bottom. So cube root of 16 is the same as cube root of 2 times 2 times 2 times 2. All right, little number here is important. It tells us now I need 3 of a kind to make a match. So 1, 2, 3 of a kind, they all get marked off, but still the same rule applies. Only one of the 2's get to go out in front. So that's it. I can only make one set of 3 right there. So now you just wrap up your question and make it look nice and neat. So 1, 2's outside. I still have a cube root, and what's left on the inside? 1 lonely 2. So our answer is 2 cube root 2 for that one. So this would be 2 cube root 2. All right, one more very similar. Number 5 here is the 4th root of 32. So same thing, we got to make a factor tree. And since this root index is a 4, I need pairs of 4. So 8 would be, you can make whatever you want, but I'm going to do 8 and 4. 8 is 4 and 2. 4 is 2 and 2. 1, 2, 3, 4, 5. Ooh, and they are all 2s. 1, 2, 3, 4, 5. Okay, let me just show you something real quick. 2 to the 5th root is 32, the same number I'm dealing with right now. All right, cool. Okay, just thought I'd show that. All right, now we're back to this. We need the 4th root of 32. So we need 4 of a kind. 1, 2, 3, 4. Mark them all off. That means 1, 2 gets to go out in front. Then it's 4th root of 2 because that's what's left. Okay, that would be your final answer. I'm going to stop the video. Email me if you have questions.